Hi there. Let's look at alcohol reactions. First, we're going to look at how to make or synthesize alcohols. So one way is alkene reactions with dilute sulfuric, dilute acid. So good example is addition of a water molecule across the double bond. So this will give you an alcohol depending on what alkene you choose. So the first one we can take, let's say we take propene. So you react with the dilute acid, catalytic H plus, and water across the double bond goes in, and then you're going to end up with 2-propanol, isopropanol. So that's a good example. And usually we don't try to produce methanol or ethanol because there are more biological methods to do it. But this is industrially we can do it, right? Okay. So the other method is amine. An amine, alkyl amine, can be converted into an alcohol. So what we need is the reaction of HNO2, and in this case it's going through a diazo salt, so and then addition of a water molecule again. Now you end up with an alcohol there too. So this is a popular method for higher alcohols. So, but this is just an example. Look at this one. Ethylamine and can be end up with ethanol. Typically we don't do this, but you can actually use sodium nitrite and HCl, and that will give you the ASA, and the ASA will be reacting with water, and diazonium salt will give you alcohol. Now, so the other synthesis method we can do, we can take a ketone and react with Grignard. So that is basically RMGX. You can choose whatever the R group you need as Grignard reagent. And this one, because you're starting with ketone, you're going to end up with secondary alcohol. Now, one example, let's take acetone, and then you react with the Grignard. And then let's say we got the Grignard with CH3, and then you're going to get this alcohol, right? This should be actually CH3, right? So that means tertiary butyl alcohol. That's what you will be getting. And it's not the hydrogen, and it should be CH3, right? So tertiary butyl alcohol. So that's what we will get. So when you use the CH3MgCl, and then there's always hydrolysis process after Grignard reactions, right? So if you learned about Grignard reactions, okay. The next method, we can do another synthesis. We can use acid. You select the acid type of acid you need, and then you can use lithium aluminum hydride to reduce it. So normally you will end up with alcohol. And this method, let's say, good example again, simplified version, acetic acid. You react with lithium aluminum hydride, and then you should end up with ethanol. Like I said, industrially we don't do this kind of stuff, right? They're not practical. Now, the other thing to be careful or to note is the alcohol type. You see this one has one R group attached. It's a primary. This alcohol has two methyl groups attached, or two R groups attached. It's secondary. And look at this one, tertiary one. You have three R groups attached to the carbon attached to the hydroxyl group. So therefore, it's a tertiary. It's a good way to think how many alkyls, how many R groups are attached to each. Look at primary. You have one R group attached to the carbon attached to hydroxide. And secondary, you have two R groups attached to the carbon attached to hydroxyl group. And tertiary, you have carbon attached to hydroxyl group, and then there's three R groups attached to that carbon. So that's the better way to count the number of R's. So that'll give you primary, secondary, tertiary, right? So these are few examples, few methods you are synthesizing alcohol. Now we're going to look at the popular common reactions you're going to see in your high school organic chemistry or first year organic chemistry. What reactions normally we see. So alcohols will react with sodium metal. Sodium metal is super reactive, and it's going to react to make the sodium salt sodium alkoxide and hydrogen gas will be released. This is an explosive reaction. You cannot try without your prof for the TA, right? And sodium reacts violently, sodium metal. Now the other one, alcohol also reacts with, in the presence of catalytic acids, and we can react with basically sulfuric acid and another carboxylic acid react with alcohol to give you the ester. So this is condensation, the Fischer condensation. That's a really important reaction B. Okay. Now, so the next one, alcohol also can react with zinc chloride in the presence of HCl. So you will get the alkyl halides. So this is another test we use. And so that's another one. So the last one is alcohols will react with strong acids like HBr, HI, whatever you're using, and you will get the alkyl halide. So it has to be concentrated, and you need vigorous conditions, and that's how you make it. And it's not a very common one that we react with strong acids and alcohols to make alkyl halides. There are better ways to do it, right? Okay. Sulfuric alcohol with conc, sulfuric, concentrated sulfuric, you can remove a water molecule and you can make a double bond that you're producing an alkene. And this can be employed normally, right? Depending on what type of alkene you need to produce. So for the first one is a hydrogen test. You can do the test, Splint. And thank you.